4.1 Graphs of the sine and cosine function. So periodic functions. Many things in life repeat with a predictable pattern, such as weather, tides, and hours of daylight. This periodic graph represents a normal heartbeat. So you see how like the heartbeat, it repeats, it goes up then down, then doot, then straight, then up, then down, then straight, then up, then down. So that's what it means by periodic graph. It just keeps repeating. Now, weather is periodic because it gets hot and then it gets cold, and we know what time of year this is. It's the same generally every year. Weather is periodic. Tides, because we know when it's going to be low tide and high tide, they're patterns, and hours of daylight. Okay, a periodic function is a function f such that f of x equals f times x plus n times p, meaning it's f of x. For every real number x in the domain of f, every integer n, and some positive real number p, the least positive value of p is the period of the function. The circumference of the unit circle is 2 pi, so the least positive value of p for which the sine and cosine function represents is 2 pi, because 2 pi is the full unit circle. Therefore, the sine and cosine functions are periodic functions with period 2 pi, and the following statements are true for every integer n. Sine x equals sine x plus n times 2 pi, and cosine x equals cosine x plus n times 2 pi. That's like math terminology of what we're about to talk about. So values of sine and cosine functions. From 0 to pi over 2, it increases from 0 to 1 for sine, and it decreases from 1 to 0 for cosine. From pi over 2 to pi, it decreases from 1 to 0 for sine, and decreases from 0 to negative 1 for cosine. For pi to 3 pi over 2, decreases from 0 to negative 1 for sine, and increases from negative 1 to 0 for cosine. And for 3 pi over 2 to 2 pi, it increases from negative 1 to 0 for sine, and increases from 0 to 1 for cosine. So meaning that's like the shape of the graph, but honestly this, you don't need to remember, because we get the shape of the graph ourselves. So for sine function, with nothing left or right of the x, it's just literally sine x. So remember, like back in college algebra or intermediate algebra, you would have y equals x squared. And then if you had y equals x squared plus 1, you went up 1 unit. So this is what we're talking about, the parent function. So before we do plus or minus or do anything to it, this is what we have. So the parent function of sine is f of x equals sine x. With that, the domain is all real numbers. So for sine and cosine, your domain can be any x value. Your range is negative 1 to 1. When there's nothing with x, your range is going to be negative 1 to 1. So when there's nothing in front right here, we have a range of negative 1 to 1. So these are our values of x and y, and this is what a sine function looks like. The graph is continuous over its domain, negative pi to pi. The x-intercepts are the form of n pi, where n is an integer. Its period is 2 pi. The graph is symmetric with respect to the origin, so the function is odd. Alright, cosine. So, domain is all real numbers. Your range is still negative 1 to 1. When there's nothing in front right here, your range is going to be negative 1 to 1. The graph is continuous. The x-intercepts are the form of 2n plus 1 times pi over 2, where n is an integer. Its period is 2 pi. The graph is symmetric with the y-axis, so it's an even function. You're not allowed to use your calculator to graph these. In this class, you have to learn how to graph the trigonomic functions using your hand. So no calculator. I have to see the work. Alright, first we're going to start off by graphing the parent function to show what it looks like by graphing by hand. So we're going to graph y equals sine times x. Now we need to find x values. This is just an interval chart, an x and y chart, aka t chart. And we're not using intervals, but it's set up like an interval chart. This is just a fancy t chart. If you took me for college algebra, you're like, oh yeah, I recognize this. I recognize this from college algebra. But now we're just using different functions. So we need to find our x values. And to find our x values, we're going to use x values in radians We're going to use x values in radians that come from the unit circle. Remember, the domain of a sine and cosine function is all real numbers. And there's nothing in front of the x. Since there's nothing in front of the x, we're just going to use the values on the unit circle. So on the unit circle, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Do you notice that these are just the quadrilateral angles? So when there's nothing in front right here, when there's nothing in front right here, your x values are going to be the quadrilateral angles. That's when nothing's in front. When something is in front of x, we completely change what we do. We have to be careful with our x values. But when there's nothing in front of x, you just use these x values of 0, pi over 2 pi, 3 pi over 2, and 2 pi. The range of y equals sine x is just -1 to 1. So when there's nothing in front of y equals sine x, there's nothing in front, your range is -1 to 1. So it's going to go into a pattern. It's going to go like 1, 0, -1. It's going to go like as a pattern with numbers. So all we do is just have to find the first one, and then we'll go with the pattern. So the only time you're allowed to use your calculator is when you can plug in the x's to find your y's. So let's go ahead and plug it in. We have sine, our x is 0, and it's 0. Then we're going to plug in pi over 2, so sine pi over 2. And you see how it's 1? That means it's going to go back to 0, down to -1, back to 0. It's a pattern. We get 0. And then it just goes in the pattern because it goes up, then down, up, then down, up, then down. That's why it goes in a pattern. And you see how there's no number in front of the sign? Well, there's a 1. That's why it goes 0, 1, 0, -1, 0. So all you have to do is find your first one, and then you'll be able to find the rest of your y values. So let's go ahead and graph this. Before we graph this, we have to fill out our chart. We would have 0, pi over 2, and then after pi over 2 is just pi. After pi, we get 3 pi over 2. And then after that, we have 2 pi. So that's the positive direction. Remember, with the unit circle, it's a symmetric with the origin, so whatever's on the right is also on the left. So we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Alright, so let's graph our y equals sine x. So we have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. You see the pattern? So all we have to do is just keep, so if we're like this, we just keep following the pattern for the negative side. So if we're at 0, 0, it's going down, so we'll have negative pi over 2, -1, negative pi 0, negative 3 pi over 2, 1, and then negative 2 pi 0. See how it's just following that pattern? So our next function, we have y equals 2 sine x. So do you notice we have something in front of the sine function now? We have a 2. So what do you think that's going to change? With our orange one, our first one, we had y equals sine x. There's a 1 in front of the sine. And we said that's why it's 0, 1, 0, -1, 0. That's why the range is -1 to 1. So if we're talking about y equals 2 sine x, what do you think the range is going to be? It's going to be -2 to 2. So this little thing right here, we're about to learn about it. We're literally about to learn about it coming up. I'm just going to give it its name right now. It's called the amplitude. Just amp. It's called the amplitude. So that tells you, the number in front of the function tells you how it stretches. What's the range? It gives you the range. So we're going to use our calculator, but before we use our calculator, because this is a positive function, it's y equals positive 2 sine x, it's going to start at 0. And then since it's positive, it's going to go up. If it were negative, it would go down. If it were negative 2 sine x, this would be -2. But since it's positive 2 sine x, we go 2 back to 0, down to -2, back to 0. We could also use our calculator. So using our calculator, we have 2 sine 0, which we're going to get 0, and then 2 sine pi over 2. We get 2, and then since it's a pattern, we know it's going to go back down to 0, but let's plug it in. So 2 sine pi, and we get 0. Then it's a pattern. So if it's going 0 to 0, it's going down to -2, back to 0. Let's go ahead and graph this. So we have 0, 0, pi over 2, 2, and just keep following the pattern. Pi 0, 3 pi over 2, -2, and then 2 pi 0. All we do is just keep, so for here, we just keep following the pattern. So it's going down. So we'll do negative pi over 2, -2, negative pi 0, negative 3 pi over 2, 2, and negative 2 pi 0. Let's talk about that amplitude a little bit more. Amplitude. The amplitude of a periodic function is half the difference between the maximum and minimum values. It describes the height of the graph, both above and below the horizontal line, passing through the middle of the graph. So you see that number 2? You see here how it's 2 away, and then here it's 2 away? That's saying that it's the highest and lowest point are going to be 2 away from the center. The graph of y equals a sine x or y equals a cosine x when a is not 0 will have the same shape as the graph y equals sine x or y cosine x respectively, except the range will be negative absolute value of a, absolute value a, the amplitude is a. So if I gave us y equals -3 cosine x, let's change that, -3 cosine 1/2 x, let's really change it here. Our range would be -3 to 3, and our amplitude would be 3. That's all it's saying with the absolute value. Alright, graphs of sine and cosine functions. No matter what the value of the amplitude, the period y equals a sine x and y equals a cosine x is still 2 pi. So did you notice, though, that when we switched it, when we put a 2 in front of the function, it still looked the same, it was just stretched. So if we have y equals 2x, one complete cycle happens in pi. When we have y equals sine 4x, one cycle happens in pi over 2. Now what does it mean by a cycle? That means how many times, when does it start to repeat? So you see how it starts at 0, 1, 0, -1? Then it goes back to 0, 1, 0, -1, back to 0. So you see how at pi, that's the repeat. That's when it starts to repeat at pi. Where it starts to repeat is a cycle. One complete cycle is pi over 2. So in pi over 2 units, that's when it starts to repeat. So you see I have 0, 1, 0, -1. Then it starts to repeat 0, 1, 0, -1. And then it'll be 0, 1, 0, -1. It just keeps repeating until forever because the domain is all real numbers. So at pi over 2, that's when it starts to repeat again. In general, the graph of a function of the form y equals sine bx or y equals cosine bx for b is greater than 0 will have a period different from 2 pi when b is not 1. So when we have a number in front of x, our cycle, our period changes. So in example 1, you see how we just knew 0 to 2 pi? That's because there was nothing in front of x. That's why we knew it was just 0 to 2 pi and we used the quadrilateral angles. But here, we're not given that. We have something in front of x. So when we have something in front of x, we need to find the period. To do that, you're going to divide the interval 0, 2 pi over b into 4 equal parts to obtain the value for which sine bx or cosine bx equals -1, 0, or 1. The values give the minimum points x-intercepts, and maximum points of the graph. So when you're finding these points using the interval chart, you're finding the minimum point, x-intercepts, and the maximum points. Find the midpoint of the interval by adding the x values of the endpoints and dividing by 2. Then find the midpoints of the two intervals using the same procedure. I'll go over that, don't worry. So let's graph y equals 2 sine 2x and compare it to y equals sine x. So I'll just compare and contrast y equals sine x, and we'll look at the differences and everything that it changes. We have now y equals sine 2x. So we have something in front of the x. So when you have a value in front of the x, you have to find the period. So our first step is to find the period. The period, it's a formula. The formula is 2 pi over b. B is the number in front of x. So we have 2 pi over b, which is 2. And when we simplify that, it's pi. So that means our period is 0 to pi. It's always going to be 0. We can also say our amplitude is 1. There's nothing in front, so it's 1. It's good to say that with the period, just get it out of the way. It's there. Alright, our second step is to find the intervals. So the first interval we find is what's the middle between 0 and pi. So to find that, to find our first interval, so 0 to pi, so 0 plus pi divided by 2, that's just pi over 2. So we have 0, pi, and then right in the middle we have pi over 2. So our period, it's what x can and cannot be. X can only be between 0 and pi. And then smack dab in the middle of 0 and pi is pi over 2. So now let's find what's between 0 and pi over 2. So we do 0 plus pi over 2 divided by 2, we get pi over 4. Now let's find what's between pi over 2 and pi. So we have pi over 2 plus pi divided by 2. So then we have pi over 2 plus 2 pi over 2 divided by 2. That leaves us with 3 pi over 2 divided by 2, which is 3 pi over 4. So now all we need to do is figure out our y's, but remember, because the amplitude is 1, it's only going to be -1 to 1. That's our range, is -1 to 1. So because there's nothing in front, it's going to be -1 to 1, and because it's y equals sine 2x, it's positive, everything's positive, we're always going to start at 0. Since everything is positive, we know it's going to go 0. If it's positive, you go up to 1. If it were negative, it would be -1. And then it goes back down to 0, then to -1, then to 0. So when you have y equals sine 2x, there's nothing happening to it's not x plus this, it's not x minus this. You're going to start at 0. You only start at 0, 0 when no plus or minus with x. So you see how there's no plus or minus with x? That's why we start at 0, 0. And then we found our intervals by dividing and finding midpoint and then quarter points. If you've taken stats, we're finding Q1 and Q3. That's what we're finding. And then we know, since we're starting at 0, 0, and it's a positive function, we go up to 1, back down to 0, down to -1, back up to 0. So your amplitude number, since it's +1, that's always going to be the next number. So let's go ahead and graph this. When we graph this, let's go ahead and fill out our coordinate plane. So we have 0, 0, and then pi over 4. Then we have pi over 2. Then we have 3 pi over 4. Then we have pi. And then on the other side, we have the same exact, just negative. So we have negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. We have 0, 0, pi over 4, 1, pi over 2, 0, 3 pi over 4, negative 1, and then 0 pi. The opposite way, we just mirror it. We just keep going with it. So it's going down, so we'll have negative pi over 4, negative 1, negative pi over 2, 0, negative 3 pi over 4, 1, and negative pi, 0. So this is our original function without adding, multiplying, doing anything to it of y equals sine x. You see how it's like really, it's more like stretched out. Like if you had a slinky, you're pulling the slinky a little bit more. But here, when we add a number in front of the x, it starts to become a little more compressed. Like you're putting the slinky together. Period. For when b is greater than 0, the graph of y equals sine bx will resemble that of y equals sine x, but with period 2 pi over b. For b is greater than 0, the graph of y equals cosine bx will resemble that of y equals cosine x, but with period 2 pi over b. Alright, let's graph cosine functions. We haven't done that yet. Let's graph y equals cosine 2/3 x over 1 period. So you notice, for example, 1 and 2, it didn't say over 1 period or anything, it just says graph. So we did the left and the right side. So over 1 period, that means just graph the right side. So we don't need to go over in that direction, we just graph the right side. We treat cosine and sine functions exactly the same when we're graphing it. We just need to find our period, our amplitude, and our x and y's. That's it. For cosine functions, you're always going to plug the first one into the calculator. Alright, let's find our amplitude and period. So the amplitude is going to be the easiest one. Our amplitude, since there's nothing in front of cosine, is just 1. Let's go ahead and find our period. So our period, it's a formula. Our period, the formula is 2 pi over b. So we have 2 pi over b. b is 2/3. So when we simplify this, we keep change flip. So we have 2 pi times 3 over 2. So we get 3 pi. So that means our period is 0 to 3 pi. That means we can find our intervals. So our intervals, another way that we could do that using pictures, because I love pictures, is actually drawing the x-axis. So the x-axis, right, it's just a horizontal line. And we know our period goes from 0 to 3 pi. So 0 to 3 pi. We just need to figure out what goes in between all that. So the first thing we do is find the middle. So the middle point is 0 plus 3 pi divided by 2, which is 3 pi over 2. Now we need to find the first quarter point. So it'd be 0 plus 3 pi over 2 divided by 2, and we get 3 pi over 4. Now, last thing we need to do is find the last quarter point. So we do 3 pi over 2 plus 3 pi, and all divided by 2. So we have 3 pi over 2 plus 6 pi over 2, all divided by 2. We're left with 9 pi over 2 divided by 2, which is 9 pi over 4. So now we have all of our x values. We have 0, 3 pi over 4, then we have 3 pi over 2, then we have 9 pi over 4, then we have 3 pi. With cosine functions, we're always going to plug the first one in to see where it starts, and then we go with the pattern. Remember, our amplitude is 1, and this is a positive cosine function. Alright, so with our calculator, we have cosine 2/3, x, and our first x is 0, and we get 1. Now we can go ahead and plug in the second one so we can really see the pattern, but always plug in that first one just to be careful. So if it's at 1, it can't go to 2 or 3 or 4. No, it's at 1. It's going to go back down to 0, then -1, then 0, then 1. But we can use our calculator. If you're unsure, use your calculator. So we have cosine 2/3 times 3 pi over 4. And we get 0. You see how it supports that pattern? You can do it all for the rest, but it's a pattern. If it's at 1, it can only go to 0, no other number. So we have all of our y values. All we do is graph. So on our x-axis, we have 0, then we have 3 pi over 4, then we have 3 pi over 2, then we have 9 pi over 4, then we have 3 pi. And our amplitude was 1. So our first point is at 0, 1. Then we have 3 pi over 4 is 0, 3 pi over 2 -1, 9 pi over 4 1, or 0, and then 3 pi over 4 1. And we connect the dots. It does curve. It's just really hard to connect the dots like this, but it is supposed to like curve a little bit like that. It's really hard to graph by hand, but we got it. So it does kind of like, it's not a parabola, it doesn't look like a U, it's just really hard to graph by hand. It does have like this weird little curve. It goes like this. It goes like that, and it's not a parabola, it's not a U, and it does stop. Why? Because it says over 1 period, so we don't keep going with the arrows. We stop it. Alright, guidelines for sketching sine and cosine functions. The graph y equals a sine bx or y equals a cosine bx when b is greater than 0. You find the period, you start off with 0 on the x-axis and lay off a distance of 2 pi over b. So meaning it's 0 to whatever your period is, and then that's going to be your period. Divide the intervals into 4 equal parts. Evaluate the function for each of the 5x values resulting from step 2. The points will be maximum points, minimum points, and x-intercepts. You're going to plot the points and then join them with a curve and draw the graph. Table should only look like this, so just block it, like scratch out the 2 first ones. That's pointless to do it that way. It's only supposed to look like this. So we're going to graph it over 1 period. Now this is where I want you to pause the video and try this on your own. It's going to be a little difficult. Be careful with that -2 in the front. So if it's negative, you should go down to -2 first. Okay, pause it, try it. Hope you did. I really hope you tried it. Graphing cosine and sine functions are super duper important, just like everything else in this class. So I really want you to try. Okay, so let's go ahead and find our amplitude. Just get it out of the way. So our amplitude is -2. It doesn't matter that's negative. It's always going to be the absolute value, so it's just 2. That means it's going to go from 2 to -2. Now we find our period. So there's a formula to find our period. It's 2 pi over b. So we have 2 pi over b. b is always the number with x. So the number with x is 3. How do I know it's always the number with x? Because period, it stands for what x can and cannot be. So that's why it's the number with x. So that is our period. I don't need to simplify. So our period is from 0 to 2 pi over 3. So we have 0 to 2 pi over 3. So I like to draw the little number line. Just makes my life easier because I'm a visual learner. So we have 0, 2 pi over 3. We have to find the first halfway mark. So halfway, that's 0 plus 2 pi over 3 divided by 2. So that's 2 pi over 6, which we can simplify to pi over 3. Always simplify. I don't need to tell you that anymore. We can find our first quarter point by doing 0 plus pi over 3 divided by 2, which is pi over 6. And then our last quarter point, we can find by doing pi over 3 plus 2 pi over 3 divided by 2. So we have 3 pi over 3 divided by 2, or just pi over 2, because those 3's cancel. So now we have our intervals. We have 0, pi over 6, pi over 3, and pi over 2. Alright, we're always going to plug that first one in to see what our pattern is. We have negative 2 sine 3x, in this case x is 0, and we get 0. Now, since it's 0 and it's negative 2, we're going to go from 0 then to negative 2. Because it's negative, we go to negative 2 first. If it were positive 2, it would go 0, positive 2. You can also plug it in. So our x this time is pi over 6. And we get negative 2. So then it goes from negative 2, then to 0, then to 2, then back down to 0. It's a pattern. Let's fill out our x-axis. We have 0, then we have pi over 6, then we have pi over 3, then we have pi over 2, then we have 2 pi over 3. So our first point is at 0, 0. And then we go down, because it's negative 2, so pi over 6, negative 2. Pi over 3, 0. Pi over 2, 2. And then 2 pi over 3, 0. And we don't put the arrows because it says over 1 period. So we start and stop. Alright, so when a is negative, the graph of y equals a sine bx is the reflection across the x-axis of the graph y equals absolute value a sine bx. So did you notice that it went down then up? When it's positive, it goes up then down, up then down. So it's just the opposite, because negative means opposite. Alright, guess what? I'm gonna ask you again. I'm gonna ask you to go ahead and try example 5. Alrighty, let's do it together. So let's go ahead and get that amplitude out of the way. I like to do it first just to get it out of the way. Our amplitude is negative 3, so it's just going to be 3. Remember, that means negative 3 to 3. Alright, now we found our period. So our period for cosine and sine, it's a formula. It's 2 pi over b. So we have 2 pi over b. B is the number in front of x. This time it's pi. So we simplify and we just get 2. So that means our period is from 0 to 2. Yes, that's possible. You don't have to have a period that has a pi in it. It's just normal numbers, 0 to 2. Awesome. That means splitting it up is going to be so much easier. Alright, let's find our intervals. We could actually do our intervals in our head. So we have 0 to 2. And then what's halfway between 0 and 2? 1. What's halfway between 0 and 1? 1/2. So if this is 1/2 and 1, then this is going to be 3/2. So in between 1 and 2 is 3/2. Because this is 0, this is 1/2, this is 2/2, this is 3/2, this is 4/2, which simplifies to the numbers above. You could also do it this way where we add the numbers and divide by 2. Alright, so we have our x values. So we have 0 to 2, and we have 1/2, 1, and 3 over 2. Alright, so let's plug in that first one to figure out where we're starting. So we have negative 3 cosine pi x. In this case, x is 0. And we get negative 3. You're noticing something about the amplitude and the first point with cosine? Yeah, you see it's there. It's something is there. If you can't see it, it's okay, but there is a trick here. For cosine functions, you see how it's negative 3 and our first one is negative 3? Here it was 1, so our first one was 1. You notice something about the amplitude and the first number? That is a pattern. Alright, let's plug in 1/2. So we have negative 3 cosine pi times 1/2, which is 0. So you see the pattern? It's going to go negative 3, 0, then 3, then 0, then negative 3. Alright, now that we have all our values, let's go ahead and fill out our coordinate plane. So we have 3, negative 3, 0, 1/2, 1, 3 over 2, and then 2. Let's plot our points. We have 0, negative 3, 1/2, 0, 1, 3, 3 over 2, 0, and 2, negative 3. And we connect the dots. It's like a little swooping type graph. Kind of goes like that. And there's our graph. Note, when b is an integer multiple of pi, the x-intercepts of the graph are rational numbers. So meaning when you have a b that is pi, so you see how b this case it was pi? You see how our intervals are normal numbers? There's no pi, they're real normal numbers. They're not irrational, they're not weird, it's just normal, average, everyday numbers. Okay, the average temperature in Fahrenheit in Mould Bay, I couldn't tell you. I've heard both. I guess Google could tell me. After all these years, you'd think I'd Google it, but I haven't. I'll stay ignorant to that. Mould or mold? I'm gonna go mould. I'm gonna go Mould Bay, Canada. Can be approximated by the function f of x equals 34 sine pi over 6 times x minus 4.3, where x is the month, and x equals 1 corresponds to January, x equals 2 corresponds to February, and so on. So June would be 6, December would be 12. A. To observe the graph over a 2-year interval and to see the maximum and minimum points, we graph f from the window 0 to 25 by negative 45 to 45. B. According to this model, what is the average temperature during the month of May? And C. What would be an approximation for the average yearly temperature at Mould Bay? Okay, a lot going on here. Let's talk about A. So for part A, that's what this first window is talking about. So why did they pick 0 to 25, negative 45 to 45? Why did they do these? It just told us to. They're going to give you part A. It's going to be there for the test, and it's going to be there for the homework. It's going to tell you what to put for part A. But now, why would I choose these values for part A? Well, I would choose negative 45 to 45 because the amplitude is 34. So 45 gives me just a little bit of extra room to see the full graph. You could also do 40. If it didn't tell us to use negative 45 to 45, I would have used 40 because it's close to 34, but that's why they chose 45 because it's close to the amplitude and it gives you a little bit of extra space in the window. They're going to give you part A, and that's just telling you how to adjust your window. That's all. Do you also notice that we are in degree mode? Why are we in degree mode? Because it told us in Fahrenheit. Fahrenheit is, you guessed it, it's degrees. Alright, so after we find the amplitude, before we talk about part B and C, what do we usually do after we find the amplitude? We find the period. So let's go ahead and find our period of this function. So since it's a sine function, our period is 2 pi over b. So it'd be 2 pi over, now the number in front of x is your b. So the number in front of x is pi over 6. Not the number with x, it's the number in front of x. So pi over 6. When we simplify this, we get 2 pi times 6 over pi, which is just 12. Now, that means the function So the function has a period of 12 or 1 year, which agrees with the changing seasons, right? The seasons repeat every year. It's not like every 3/4 of a year we get a season. No, every year the seasons repeat. It goes, right? If we start at January, it's winter, spring, summer, fall, winter, spring, summer, fall, winter, spring, summer, fall, 0, -1, 0, 1, 0, -1, 0, 1. You see how it's that pattern? That's what we're talking about because it's sinusoidal or periodic. It's a pattern because it's a periodic function. All right, let's talk about B. All right, so B is asking, according to this model, what is the average temperature during the month of May? So May is the 5th month of the year. Since it's the 5th month, we're saying x equals 5. So all we do is just plug in x for 5. So we have y equals 34 sine. I'm plugging this into the function they gave us. 34 sine pi over 6 times x, which is 5, minus 4.3. Now let's plug that into our calculator. Exactly how it looks on the page, let's plug it in. We have 34 sine pi over 6 parentheses 5 minus 4.3, 5 minus 4.3, and we get about 12.18, so in degrees we get 12. So it's approximately 12 degrees. So that means the average temperature in May in Mould Bay is 12 degrees. That is their average temperature, 12 degrees Fahrenheit. We have to say Fahrenheit because Celsius and Fahrenheit are very different. The average temperature in May, in this part of Canada, is 12 degrees Fahrenheit. Our average temperature is like 85, 90 in May. No thank you. To them. Alright, so that was part B. Part C, what would be an approximation for the average yearly temperature in Mould Bay? Alright, part C is this graph right here. So we have to do these two parts to get the graph. I'm going to show you how to graph this using our calculator. So you hit y equals, and you're going to plug in the function exactly the way it looks. 34 sine pi over 6x minus 4.6. Now your window should already be changed. Your window should already look like that. If not, hit window and change it. And then from there you hit graph. And see how it matches the graph? So do you notice that it kind of straddles the 0 line, x at 0, right? It goes just above 0, back to 0, down 0, up, back to 0. You see how it's always coming back to 0, and it's kind of like the halfway mark. If you put that there and if you folded it over, isn't it going to go on like kind of like halvesies? So from the graph, it appears that the average temperature is about 0 degrees because the graph is centered around y equals 0. Alright, so we're not done yet. I want to go back to B real quick and show you another way you could have done B. There's another way we could have done B. Alright, another way we could have done B is to actually use our calculator. So the first thing you do is you plug it into your calculator. So you plug our function in, how we did in C right here. You plug it into our calculator. And then what we do is you're going to press second trace, press 1 for the value. The x will appear with the graph will appear with an x flashing at the bottom. Input x is 5. Press enter. And then at the bottom of the screen, it'll show you your y value. Now you can do this with anything. If you want to plug x into anything, you can do this. So let's actually do this with our calculator. So you plug in your function, you leave x as x. Then you hit second trace. You hit enter because it's value number 1. And at the bottom, you see how it says x equals flashing? You're going to hit the x you want to plug in. We want to plug in 5, hit enter, and then it gives us our y value. You can do that with any function. Anytime you want to plug x into something, you can use your calculator, and it'll give you your y value at the bottom. So for the test, word problems, use your calculator. You do not need to show me work. But when we're graphing by hand, like example 5 and on, and example 1 through 5, you have to show me your work. What does it mean to show me your work? Now this part right here, your period, some of you can do this, what I circled in your head. That's fine. You don't need to show me that. Some of you can do that with your head. What I'm going to be looking for is our chart, our amplitude, and our period. Of course, then the graph. So what I'm checking off in red is what I'm looking for is the chart, the amplitude, your period numbers, and the graph. Everything else you don't really need to show because you can do it in your head or use your calculator to do numbers. Right here is just adding and dividing fractions. That's all we're doing right there.